Hey everyone, and welcome. Okay, let's just jump right in. Today, we're tackling a topic so incredibly massive, it's honestly known for making grown developers cry: Kubernetes. But look, we're not going to sit here and just read off a dry list of textbook terms. Instead, we're going to completely demystify all 75 core concepts from our source material by looking at the whole thing as one giant, living ecosystem. To pull that off, we need a complete paradigm shift right out of the gate. Our source material hits us with this absolute gem. Kubernetes is not just a container orchestrator, it is a distributed systems kernel for the cloud-native era. Think about that for a second. That changes the whole game. We really have to stop looking at Kubernetes as just some neat deployment tool. It's essentially a massive operating system for your entire cluster.
So here is our roadmap for this explainer. We'll start with 1, the distributed systems kernel, then 2, core architecture and workloads, and 3, traffic, configuration, and storage. After that, we'll hit 4, security, operations, and tools, 5, advanced scheduling and extensibility, and finally, 6, your customized learning path. I know it sounds like an absolute avalanche of buzzwords, but don't worry, we've got it all neatly organized right here.
All right, let's kick things off. Section 1, the distributed systems kernel, building the foundation. Right away, you'll notice this really distinct split between the brains and the brawn of the architecture. Over on the left, we've got the master nodes. This is your control plane, literally the brain of the operation. It's got the API server taking all your commands, etcd acting as the absolute strict source of truth, plus the scheduler and the controller manager. Then on the right side, the worker nodes. That's the brawn. This is where your applications actually live and breathe, managed by local node agents and container runtimes.
And speaking of where your code lives, we have got to nail down this absolutely crucial definition right now: the pod. It is the smallest, most basic deployable unit in Kubernetes. Basically, a pod represents a single instance of a running process. The big takeaway here: Kubernetes actually doesn't run containers directly. Nope, it wraps them up inside pods and runs those. Literally, everything else we are going to cover in this explainer exists for one single reason: to support, manage, secure, or connect to these pods.
Okay, moving right along. Section 2, core architecture and workloads, the forever runners.
So how does Kubernetes actually manage the life cycles of the apps inside those pods? Well, it uses different workload controllers. You've got deployments, which give you seamless rolling updates with zero downtime. ReplicaSets act like strict bouncers, making sure an exact number of pod copies are running at all times. Then there are stateful sets, super important for things like databases that desperately need stable, persistent identities. Daemon sets guarantee that exactly one pod is running on every single node. And finally, jobs and cron jobs, which handle your scheduled batch processing. It's automation at its finest.
But, as you might guess, all this powerful automation brings up a pretty massive operational problem. Pods are completely ephemeral. I mean, they die, they get recreated, and their IP addresses change every single time they do. So, if everything is constantly shifting around like that, how do they reliably talk to each other?
Which brings us to the next piece of the puzzle. Section 3, traffic, configuration, and storage. Let's look at the connective tissue.
To solve that incredibly annoying ephemeral networking puzzle, we introduced the traffic director layer. Services step in to give us stable, unchanging IP addresses. So even if the underlying pods die and shift around, that service IP acts as a permanent anchor. Then you have ingress, which is basically your traffic cop for the outside world, managing external HTTP routing into your cluster. Network policy acts as a strict pod-level firewall, and running quietly under the hood, CNI plugins like Calico or Flannel are what actually handle the heavy lifting of the network implementation.
Now, networking isn't the only connective tissue. Our pods also need rules and data, and you really want to notice the strict divide we maintain here. On the left, we have config maps. These store your everyday, non-sensitive key-value pairs, stuff like environment variables. On the right, we have secrets. These are for your highly sensitive data. Please, I'm begging you, do not put your API keys in plain text. Secrets are base64 encoded and encrypted at rest inside etcd. The golden rule here: always separate your immutable application code from its runtime configuration.
All right, what about persistent data? Because if a pod dies, any local storage it was using dies right along with it. Well, here's how Kubernetes gives those pods lasting memory and matter in 3 simple steps.
Step 1, a storage class dynamically provisions the physical storage. Step 2, a persistent volume, or PV, represents that physical storage as an actual cluster resource. And Step 3, a persistent volume claim, or PVC. This is basically an application pod raising its hand and requesting a specific chunk of that storage. This whole chain is exactly how you securely attach permanent data to a highly temporary pod.
Moving on to our next layer, Section 4, Security Operations and Tools, the defenses and controls. Because Kubernetes is, at its core, a distributed systems kernel, we need some incredibly strict defenses. Enter the gatekeeper. First up, RBAC, Role-Based Access Control. This determines exactly who is allowed to do what. Service accounts give your pods their own unique identities so they can securely talk to the API. Pod security standards dictate your isolation levels, which stops pods from doing things like hijacking the host node. And finally, admission controllers. These actually intercept API requests and ruthlessly enforce your custom policies before anything is even allowed to execute. They do not mess around.
But look, security is just one piece of a production environment. A raw vanilla Kubernetes cluster is almost never enough on its own. You really need the operator's toolkit. We're talking Helm for packaging up your applications and Customize for dynamically tweaking all that YAML. For visibility into what's actually happening, Prometheus and Grafana are there to collect and visualize deep metrics, while FluentD aggregates your massive piles of logs. And when traffic spikes, tools like the Cluster Autoscaler will literally add or remove physical hardware nodes on the fly. It's pretty amazing.
Okay, we are entering the masterclass now. Section 5, Advanced Scheduling and Extensibility. Let's dive into what we call the scheduler's dilemma. How do we control exactly where our pods run? Notice the two completely different approaches here. On the left, taints and tolerations. This is all about repelling pods. It's basically a node saying, unless you have a specific toleration, stay away from me. It's absolutely perfect for dedicating specific nodes to GPUs. On the right side, we have node and pod affinity. This is about attraction. It lets you say, hey, I want this front-end pod co-located right next to this back-end pod. It gives you that exact granular control over placement. But the true, undeniable magic of Kubernetes, it's infinitely extensible. This is how we go way beyond vanilla Kubernetes. You can create custom resource definitions, or CRDs, which literally teach Kubernetes entirely new concepts, like what a database or a backup actually is. You combine that with the operator pattern to build your own custom controllers, leverage API aggregation, tap into the massive CNCF ecosystem, and boom! This is the exact moment you transition from just using the platform to actually building the platform.
And finally, Section 6, your Kubernetes learning path. Let's put all of this together.
I know we've covered a lot today. There are literally 75 concepts represented in our source material, and it is so incredibly easy to get overwhelmed. So I highly encourage you to take a screenshot of this matrix right now. It totally cuts through the noise and tells you exactly what to prioritize based on your actual day job. Are you totally new to Kubernetes? Focus strictly on architecture and workloads. Are you an app developer? Zero in on workloads, config, and networking. Cluster operator? Your whole world is security, operations, and scheduling. And if you're a platform builder, extensibility is your domain. Seriously, don't try to learn it all at once. Just learn what you need to solve the problem directly in front of you.
Which leaves us with one final, kind of provocative question for you to chew on. Are you building an application or are you building the platform? You've got to choose your path, because as we established right at the very beginning of this explainer, Kubernetes is not just a simple tool. It is a living kernel. How you interact with it entirely depends on what you were trying to build. I really hope this explainer has given you the precise map you need to start navigating this wild, incredible cloud-native ecosystem.